Uh, good morning, friends. Welcome to another session of moving charges and magnetism, part 3. So it's moving charges and magnetism, part 3. This is what we're doing. So in this one, the first one is magnetic field due to a current carrying conductor of finite length of finite length. So here there is a conductor. What you have, the conductor is of length L, you can think of. And now from the center of the conductor, we have taken a perpendicular distance. The point P resides at a perpendicular distance of R. Okay, you can think of like that. And now this edge, from this edge, we draw a line like this, and from this edge, okay, we'll put the point P here. From this edge, we'll draw a line like this. Now, uh, let me give a different color, and this one, let us say alpha, and let me give a different color. This one, let us say it's beta. These are the two angles which is subtended. Okay, fine. So you have alpha and beta. These are two angles. Now, this conductor, there is a current which is flowing through this conductor, that is I. The expression for the magnetic field is given by mu naught I by 4 pi r, mu naught I by 4 pi r into sine alpha plus sine beta. So this is the expression. You got to remember this expression. Based on this, we'll solve a problem. So what if the thing is that now from this condition we have for an infinite conductor, the alpha and beta goes to 90 degrees. Why it is so? See, imagine this conductor is going like this. The ends of the conductor, if they are joined like this, the angle keeps increasing. The alpha also increases and the beta also increases. So if the conductor extends to the very large, okay, now if the conductor extends to the top like this, the angle keeps increasing. When it goes to infinity, it becomes like this. Okay, the angles will become 90 degrees. Okay, the conductor extends, the angles go closer to 90 degrees. This is what the scenario it is. So that's why alpha beta 90. When you substitute that, you will end up with the magnitude of the magnetic field is given by mu naught I by 4 pi r, and you have sine 90 plus sine 90. So sine 90, this part is sine 90 plus sine 90. Sine 90 value is 1. So this happens to be 1 and this happens to be 1. 1 plus 1 adds up to 2. So you have the value of B is mu naught I divided by 4 pi r times 2. So this one and this one gets cancelled out. So you can make a note up here. So for an infinitely long conductor, for infinitely long conductor, the value of B happens to be mu naught I by 4 pi r times 2. So this one and this one gets cancelled. So you have mu naught I divided by 4 pi, sorry, 2 pi r. So 2 pi r is, that's the formula for an infinitely long conductor. So please note, after here we'll solve a problem. We'll solve some two problems and we'll close. So here, so the problem one is that find an expression, find an expression, find an expression for the magnetic field, for the field, magnetic field at the center of the coil, at the center of the coil, bent in the form of a square, bent in the form of a square, bent in the form of a square of side 2a, of side 2a, okay, carrying a current I, carrying a current I as shown in the figure. So carrying the current I, okay. So I'll show that in the figure, that need not write about that. So it's here, you have, it's like this, and the current is flowing through this one. So this is of side length 2a, and at the center of this conductor we have to find. So let us say ABCD is the conductor and the center is O. At O, what is the magnetic field is what we have to find. Now let us say the current I is flowing through that. Yeah, we know that they have given this. Now let's join this here, and let me change the color. So this perpendicular distance is from the center. If we cut, this length is A, this length is A, this length is also A, you have. Now this angle here is about 45 degrees. This angle is also 45 degrees from geometry. This is well known fact. Now it's like this edge is contributing to certain magnetic field. This edge will also contribute the same amount of magnetic field. So that is 1, 2, and this side will also contribute. All the four sides will contribute to the magnetic field. That is the fundamental idea. So it's like the answer will be 4 times the net magnetic field at the point O is the 4 times the magnetic field what you have. So the 4 times the magnetic field we have to find. What is the magnetic field? Mu naught I by 4 pi r into sine alpha plus sine beta. Here alpha beta is equal to 45 degrees. So that's sine 45 plus sine 45. That's how you have. Okay. And now that is 4 into mu naught I by 4 pi r. Sine 45 is 1 by root 2 plus sine 45 is 1 by root 2. So here you have 4 into, so this, let's cancel this 4. Mu naught I by pi r into 2 by root 2. This is what you have. Root 2 and 2 gets cancelled. So you have the final answer, that is root 2 mu naught I divided by pi r. So that's the answer you have, root 2 mu naught I by pi r. So here r is A, here r value is A. That's the side length which they have given. This r value is A here. So substitute r is equal to A. So you have the B net is root 2 mu naught I divided by pi a. That's the answer for you. So have a note. So in the earlier expression, if you have, this is the coil and this is the length r, we have taken, instead of r, we have a here. That's only the variation you have. So as per the formula I did, now r value is a is the substitution we have to give. Don't forget the substitution. So that's the answer for you. So let's move on to the next one. Let's move on to the next question. So I'll be clearing this. So next, move on to the next question. Second question. A current of 10 amps, a current of 10 amps is flowing east to west, is flowing east to west, east to west in a long wire, in a long wire, in a long wire, kept horizontally, kept horizontally in east to west direction, in east to west direction, in east to west direction. Find the magnitude, find the magnitude, magnitude and direction of magnetic field, and direction of magnetic field, magnetic field in the horizontal plane, in a horizontal, in a horizontal plane, in a horizontal plane at a distance of 10 centimeter north, at a distance of 10 centimeter north. So this is the one you have now. So you can make a note of this one. So we'll do this from, see, east to west. It is moving from east to west. The current is moving from east to west in a long wire kept horizontally east to west. Okay, east to west uh, is moving from east to west. Okay, 10 amps current. So current, how much we can write? That is 10 amps for you. And in a long way, this is the next funda. If they say long, long enough means that's a situation of infinite wire. Okay, infinite wire. So if they say long, you can consider the situation to be an infinite wire. So I is about 10 amps long wire kept horizontal in east west direction. Find the magnitude and direction of the magnetic field in the horizontal plane. So the first part is like you have this is the knot on the point is about 10 centimeters away from the wire. So the distance of the point, that is r, that is about 10 centimeters. So that is 10 into 10 to the power of minus 2 meters. So that is zero point 0.1 meters. That's the value of r. So the magnetic field, we can just calculate what's the magnetic field. So B is about mu naught I divided by 2 pi r. That's the expression for us. And now that is mu naught by 2 pi is about 2 into 10 to the power of uh, so that's 2 into 10 power minus 7. Mu naught by 2 pi will be, and I is about you have 10 amps, and that's r value is 0.1. So let's work out the answer. So it's about that is 2 into 10 power minus 5 Tesla. So when you work out, that's 2 into 10 to the power of minus 5 Tesla. That's the amount of magnetic field. Now, how to see the direction? You can put your thumb in this direction, and when you curl the fingers, the curl of the fingers will go inside the plane of the paper. So the magnetic field is directed into the plane of the plane of paper. So that's how one can take the conclusion. So these two problems. We will at this point we'll stop the video, and then we will see in the next video what we can will see the circular coil and the loop kind of stuff. So that we'll see in the next one.